This is a video on solving basic, or not necessarily basic, but solving linear equations. And I'm assuming that you've already done some work with solving equations, and so I'm going to do a quick reminder that the idea is that you take an equation like this and you want to write a series of equivalent equations till you get one that's easy to solve. So like, for example, here, 3x plus 2 equals 5. We know there's a series of properties of equalities that says if you do the same thing to both sides of the equation, if you perform the same operation to both sides of the equation, then the equation remains an equivalent equation. So for example, here, if I subtracted 2 from both sides of this equation, I would get 3x is equal to 3. And the idea is that this equation is equivalent to that equation, which means the solution to this equation is the same as the solution to that equation. And the idea is that this is an easier equation to solve. In fact, we could go one step further and divide both sides by 3, and we end up with x equals 1. And that, of course, is a very simple equation to solve, and it is still an equivalent equation with that one, which is also equivalent equation to that one, which means the solutions to this equation are the same as the solutions to that equation. Okay? So that means the answer would be x equals 1. That's the solution to that equation. And just to check, if you take 1 and plug it in for x, what do we get? 3 times 1 is 3, plus 2 is 5. Sure enough, we get what we're supposed to get. So just to remind you, when you're solving an equation, that means that you're looking for a number that you can replace x with that will make the equation true. Okay? So in this case, we found it. If I plug 1 in for x, it makes the equation true, because 3 plus 2 is equal to 5. Okay, likewise in this one, again, I want to just undo the things that are being done to x so I can get a simple equation like this over here. So looks like if I subtract 8 from both sides or add a negative 8 to both sides, I get a negative 4x is equal to 10. And then I would divide both sides by negative 4, and I get x is equal to a negative 2.5. And that would be the solution to my equation. Okay, that's the idea. So then, of course, we're going to want to be able to do something that are a little bit more complicated than this. Like, for example, if I have a 3 times x plus 2 minus 4 times x plus 7, and that's supposed to be equal to 10x plus 8. Okay? So here we got variables all over the place. We got numbers all mixed together. We got parentheses. So we have to use, we're still going to use the same concept here. We're trying to get a simple equation like this by doing a series of things to the original equation. But we're going to use all the skills that we've developed so far in simplifying, because what I can do besides adding the same thing or doing the same operation to both sides of the equation, I can also just simplify one side of the equation. So in other words, I don't have to, if I distribute the 3 through here, I don't have to do anything to this side, because I'm just doing something that we all know is possible because of our skills at simplifying expressions. I'm just simplifying the left side of the equation. So if I do that, I get 3x plus 6. And then I'd also distribute this negative 4 through, so that'd be negative 4x plus negative 28. Okay? And then I can't really simplify this side, so I just leave it as is. Okay, so now we've simplified one side. We actually are not done because we have like terms here, don't we? So 3x and negative 4x, that would be a negative x. And a 6 and a negative 28, that'd be a negative 22. And now we're getting close to we can do something. So we've simplified the left side of the equation. The right side was already simplified. So now, since our goal is to get something like this with the x by itself, that means we need to get the x's on the same side of the equation, because it's impossible to get x's by themselves if you have an x on the left side and the right side. So how can I get the x's together? Well, I'm just going to add an x to both sides of the equation. It doesn't matter which side I get them on as long as I get them together. Clearly, negative x plus x is 0, so that leaves just a negative 22 over here. And 10x plus 1x would be 11x. Of course, that 8's still sitting there. Now we have an equation similar to these ones we did up here. So the next move would be to subtract 8 from both sides. And we end up with what? Negative 30 is equal to 11x. Divide both sides by 11, and we get negative 30 over 11 is equal to x. And that would be my solution to this equation. Okay, so the concept that I just illustrated was sometimes we need to simplify one or both sides of the equation before we start performing the same operation to both sides to break it down to a simpler equation like this. Okay, so that may mean multiply out or distribute through a parenthesis, or it may just be combining like terms. Like you could have something like this where you have 5 plus 2 times x plus 8 is equal to 3x minus 7 or whatever. Okay, so in this case, again, I can't, there's no simplifying to do to the right side of this fraction, but the left side I can. So I'll leave the 5 alone, and I'm going to distribute the 2 first. So that'd be 2x plus 16 equals 3x minus 7, right? And then I can simplify this further. That'd be 2x plus 21 is equal to 3x minus 7. And now I want to get the x's together, so I'm going to subtract 2x from both sides. And that gives me a 21 on this side, and an x on that side, minus 7 that is. Add 7 to both sides, and I get 28 is equal to x. Okay? Now sometimes you may not want to simplify it. Like for example, if I have 4 times x plus 2 is equal to 8, rather than simplifying the left side, I might divide both sides by 4 right now. Because if I divide both sides by 4, notice the 4's cancel here. I'm left with an x plus 2, and 8 divided by 4 is 2. Subtract 2 from both sides, and I get x is equal to 0. Okay? Now, what if we would have done it the other way? 4 times x plus 2 is equal to 8. Well, if I were to simplify first, I get 4x plus 8 is equal to 8. Subtract 8 from both sides, and I get 4x is equal to 0. Divide both sides by 4, and I get x is equal to 0. Okay, so it doesn't matter. As long as I follow the rules, I can do it in either method. Okay, another concept I want to make clear to you is sometimes we have fractions in our equations. Like for example, that's not a fraction. For example, if we have like x over 3 plus 2 thirds is equal to say 3 halves x minus 5. Okay, so in this case, this is, remember when we were doing when we were simplifying complex fractions, we use the method of busting up the fractions or getting rid of the fractions first. So I could kind of move these, get the x's together and do all this stuff with fractions, but I think that integers or whole numbers are a lot easier to deal with than fractions. So the first thing I would do is multiply both sides of this equation by a common denominator of all the fractions. That way I wipe out the fractions. So if I look at the 3 fractions, we have a denominator of 3, 3, and 2. That means the common denominator would be 6. So I'm going to multiply this side by 6 and this side by 6. And when I multiply 6 times that, I get 2x. When I multiply 6 times 2 thirds, I get 4. When I multiply 6 times 3 halves, I get 9x. And when I multiply 6 times negative 5, I get negative 30. Right? So now I've eliminated the fractions. They're just nice integers left, so it'd be easy to move them around. So then I go ahead and get the x together. That'd be minus 2x minus 2x. And I get 4 is equal to 7x minus 30. Add 30 to both sides, and I get 34 is equal to 7x. Divide both sides by 7. I get 34 divided by 7 is equal to x. And that would be my solution to my equation. Okay. We haven't found yet? Okay, every once in a while you'll get a problem like this. It's very interesting. Like, for example, 3x plus 2 is equal to, let's say 3x plus 6 is equal to 3 times x plus 2. Now, if you have good algebra eyes, you're going to notice right now that those are actually the two sides are the same as each other. But let's say you didn't notice that. So you might distribute 3x plus 6 and is equal to, so I'm simplifying the right side this time, that'd be 3x plus 6. And then you try to go to get the x's together. So you subtract 3x from both sides, and what in the world? I end up with 6 equals 6. There's no x's. The x's have disappeared, so I can't solve for an x anymore. But I notice that I am left with an equation that is always true. Right? We know that 6 is always equal to 6. So that means that this original equation is what we would call an identity. Meaning that this equation is true no matter what I replace x with. So this equation is true for all x. So that's called an identity. Or we may have something like this, where I have 3x plus 6 is equal to 3x plus 2. And once again, when I go to solve, I get the x's together. I go 3 minus 3x from both sides. And I get 6 is equal to 2. And now we're left with an equation that's never true. 6 is never going to be equal to 2. So that means that there is no solution for this equation. In other words, there isn't any x's that'll make this equation true. This one, every single x we put in here is going to work. It's going to make the equation true. And this one, I can't find any x's that'll make it true. I think XYZ calls this option, is it incongruent? Is that what they called it? I forget what they called it. Let's see. A contradiction, that's what they call it. It's a contradiction. Yep. So basically just there is no solution. So you'd say that this equation is a contradiction because you can't make the two sides equal to each other. Okay, I think I'll pause. I'll end the video on that one. So that's a good lesson on solving equations to get you started. There'll be some practice worksheets posted, and I'll work through those practice worksheets probably tomorrow. All right, have fun.